We are discussing moderation and interaction in this video series, and in the last video, I was looking at a model in which we could predict IQ based upon certain select physical characteristics, and we ended up choosing a model in which we used brain size and height of the individual in order to predict IQ. We also looked at how we could hold the height constant and still look at the influence of brain size on IQ. And I here show that at 65 and 75 inches that we have the same effect, that is, the slope is the same. We have the same effect as 65 inches as 75, not because there's no interaction, but because I have not even considered interaction yet in the model. So there is no interaction in my model, but that doesn't mean that there will not be interaction when I consider it, and that's what I'm about to do now. So let's consider the possibility of interaction. And here is the main event when it comes to interaction. What I've done is taken brain and height and created what we call a cross product. That is, I simply multiply them together. Now, brain will still be in the model, and height will still be in the model, and I highly advise that you always include brain and height in the model when you look at interaction. And in fact, that's what R is going to assume, is that anytime you put in an interaction, it will automatically put in brain and height. And meanings change, and change in ways you would have to really dig deep and think carefully about how to interpret if you take those out when you're putting interaction in. So when we study interaction, we leave in these potential main effects, even though we already know that if there is interaction, the main effects are going to be hard to interpret. And we'll probably focus just on interaction and looking at how we can interpret for various values of, for example, like we did up here, various values of height. So let's go ahead and look at that model. And what I see in that model is that I have a really high p-statistic for interaction. This is suggesting to me that high p-statistic and that tiny, tiny effect size of, for all intents and purposes, 0. This is telling me that there is no interaction. The other thing I notice is that my two stable predictors of height and brain size that were so stable before, now I have a lot of instability. That is, if I were to take this model and obtain another sample, things are likely to be quite different because all of these p-statistics are quite large. So even though my multiple r squared did not drop, because it will not drop, the multiple r squared is going to only increase whenever you add variables. So it's 0.295, and let's see what it was back up here. It was, here it is. It was 0.2949, so barely changed. Look by contrast at the adjusted r squared. That one can go down when you add variables if they're not contributing. And indeed, we went from 0.2546 here to down here we have 0.2327. So adjusted r squared dropping is not a good thing. Okay, so I'm thinking there is no interaction, but before we let it go, let's look at a picture. And I'm drawing this picture very similarly to what I did above, but you will see one difference. Notice how many coefficients I have here? I have 3. Notice how many coefficients I have here? I have 4. Why? Well, look at this model. We have the intercept, that's 1, plus 2, 3, 4. And so if you look down here, I have 4 coefficients. Now I'm still leaving the height at 65 inches in order to get predictions of IQ when the height is 65. And that's going to appear in 2 places. Look back at our model. It's going to appear right here for height, but it's also going to appear here multiplied by brain size. So that's why you see down here a 65 for the third coefficient, which is for height, and also a 65 for the interaction coefficient, but 65 multiplied by brain. I want brain size to vary, but I want to keep height constant. And down here, everything's identical, except that we put in a 75 instead of a 65 to get a prediction for IQ when the height is held constant at 75. And then I do my plot and my line, and what do I get? Okay, now when you compare the two pictures, they look identical. There's the first one, there's the second. There's a big difference. One picture, this one back up here, was forced to have parallel lines because we did not include interaction in the model. This one was not forced to have parallel lines. We did include interaction in the model. It's just that there is none. And so when you see those parallel lines, that is the same slope, which means the same effect of brain size on IQ no matter what the height is, when you see parallel lines like this, when there is interaction in your model, you know that, hey, I let it vary, I let it see if there was interaction, and nothing showed up. And so therefore, the next step that I would take is to take the interaction right back out of the model. So therefore, what I would end up with as a model is the one right up here that we had predicting IQ from brain size and height. I have two stable predictors up here, unlike when I included the interaction, and I don't see any sign of interaction down here. In the next video, I'm going to give an example in which there is going to be interaction. So I'll join you there.